Now is a good time to pull out the slope formula and the distance formula to verify that the triangle midsegment theorem actually works. Keep in mind that we're only verifying this. We'll actually prove it later. So we're given triangle ABC with vertices at 0, 0, 6, 8, and 8, 0. And we're asked to verify the triangle midsegment theorem using segments AB and AC. Our first step is to use the midpoint formula to find the midpoints of segments AB and AC. Wow, I forgot about that one. We're going to be using all of our theorems here. Here's the midpoint formula. Now we'll plug in our x-coordinates and our y-coordinates. So we have 0 plus 6 divided by 2 and 0 plus 8 divided by 2. And that gives us the coordinate of D, 3, 4. That's the midpoint of segment AB. Now we'll find the midpoint of segment AC. Once again, we just simply plug in the numbers 0 plus 8 divided by 2, and the y-coordinates are much easier, 0 plus 0 divided by 2. That gives us the coordinates of 4, 0 for E, the midpoint of segment AC. Now we can quickly draw in the midsegment, and we can get started with everything else. Moving on to step 2. In step 2, we're going to use the slope formula to find the slopes of the midsegment and the third side, segment CB, and by showing that they have the same slope, we will verify that they are parallel. So using the slope formula, we'll plug in the y-coordinates on top and the x-coordinates on bottom, and we find out that the slope of segment DE is negative 4. And for segment BC, 0 minus 8 are our y-coordinates, 8 minus 6 are our x-coordinates, and we find out that segment BC also has a slope of negative 4, making the two segments parallel. Our third step is to use the distance formula to show that segment DE is half as long as segment BC. Now the distance formula is a little bit more complex, so let's go through it here. For segment DE, we use our x-coordinates and subtract them, 4 minus 3. Our y-coordinates and subtract them, 0 minus 4. We'll square both of those differences and take the square root, and that gives us the square root of 17. And segment BC is absolutely no different. 8 minus 6 squared plus 0 minus 8 squared. That is the square root of 68, but 68 is 4 times 17, so that reduces to 2 times the square root of 17. So finally, we realize that they both have a slope of negative 4. Same slopes means they're parallel. And since DE is the square root of 17 and BC is 2 times the square root of 17, then DE is half of BC. Thus, we have verified the triangle midsegment theorem for this triangle ABC.